solving with substitution is a second method for solving a system of equations. Now, what's true about all these solution methods, graphing, substitution, or elimination, is that you can use any of them anytime you want to. So it's not like this problem can only be solved with substitution. If you wanted to, you could solve this problem by graphing, you could solve this problem with elimination. It just really depends on your preference. But let me go ahead and show you how the substitution method works to solve a system. So first thing first, to solve using substitution, one of your two equations needs to be solved for one of your variables, meaning one of them needs to say either y equals blah 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 or x equals blah 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 blah. So in this case we have that. We have our first equation is solved for y. It tells us that y is equal to 2x. So what I want you to do is circle what y, or x if it happens to be the case, is equal to. So y is equal to 2x. What that means is anywhere you see a y, you can replace it with a 2x. They're equal to each other. So from what you circle, draw an arrow pointing to the other y, because that's what we'll solve for, in the other equation. And then what we're going to do is we're going to rewrite that equation, but in place of y, anywhere I see a y, I'm going to write a 2x instead. Everything else remains the same. So if like 4x stays 4x, instead of doing minus y though, I'm now doing minus or subtracting 2x. And then again, continue writing, everything else remains the same. Think about when you have a substitute teacher. Your teacher is replaced, your teacher's not there, but everything else is the same. The classroom is the same, the kids are the same. You're all doing the same amount of work, right? When there's a sub there. So everything is equal other than the teacher's gone and something has replaced it. Well, look what we have now. Why this is now easier for us to do, or possible for us to do, is we only have one variable. Well, two variables of only one different variable. And we can solve that algebraically. So let's combine some like terms. 4x minus 2x is 2x equal to 6, and I'll divide, and I get x equals 3. Well, when you get one answer, don't think you're done though, because we're looking for an ordered pair. We're looking for an intersection point, a solution to the system. So every x needs a y, and every y needs an x. So once you find one variable, you're not done. What we'll do though is we're going to take that variable all the way back to the beginning and replace that value in one of the equations. So I'm actually going to go back and replace this in the very top equation, because it's kind of like a formula to find y. It says to find y, just do 2 times whatever x is. Well, I now know x is 3, and so when I multiply, I get y equal to 6. Now, if you gave me that as an answer, I'd be okay with it. Those are the two answers, 3 for x and 6 for y. But remember, what we're doing is we're actually finding a coordinate. So what I'd ideally like you to do is write that answer as an ordered pair. X is always first, no matter what order you found the variables in, and y is always second. So 3 comma 6 should be the solution to that system. Let's also go ahead and do one more example where it's not quite so easy. So again, I want to use substitution, although it's not the only method. I could certainly use a different one if I wanted to, but let me show you how this substitution method works. Now, I had said last time that in order to start, one of your two equations needs to be solved for one of your two variables. So I need something to say x equals or y equals, and right now I don't have that. So the first step this time is going to be to rearrange one of our equations so it does say that. I'm free to solve for any one of these 4 variables. However, one of them is going to be the best bet to solve for, the easiest one to solve for, and hopefully what you're thinking is what I'm thinking, and that's going to be to solve for this x. If I solve for any of the other variables, that would work, but I'd end up having to divide by 2 or dividing by 5, and I don't want to work with fractions, I don't want to work with decimals if I don't have to. So let's take this bottom equation and rearrange it so I solve for x. So I'll need to subtract 3y from both sides. So my new equation is going to be x equals negative 3y and then plus 3. So now I'm free to go ahead and start substitution. So what I like to do is circle what I'm subbing in. So circle the negative 3y plus 3. I'm going to draw an arrow pointing to the x, because that's what this is equal to, in the other equation. So I'm going to point to that x up there. Don't try to sub into the equation you just rearranged from. It's going to be weird. You're going to get confused, and don't do that. So sub into the other equation, the one you did not rearrange. Okay, and then what I'll do is I'm going to rewrite everything, but in place of x, put negative 3y plus 3. So I have 2, and I want to show 2 times x, but in this case it's 2 times this entire quantity, so make sure you use parentheses, so 2 times negative 3y plus 3. And then remember, continue writing everything else out exactly the same as it was, so plus 5y equals negative 5. And then if you take a look, once again, why this has helped us is now I only have one variable. It's just a y, and I can solve an equation with one variable in it. So I'm going to go ahead and distribute, so negative 6y plus 6, and then plus 5y equals negative 5. And let's just kind of proceed from there. So I'll combine some like terms and get negative 1y, excuse me, plus 6 equals negative 5. I'll subtract a 6, so I have negative y, or negative 1y, equals negative 11, and then divide by negative 1. So y must be 11. Hooray, we got our first variable. But don't forget, you need a second one. Every y needs an x, and every x needs a y. So take your y back to the top and replace it in one of your equations. You can use either one, the top equation or the bottom equation, or you're even welcome to sub back into the equation you rearranged, which I like to do when I substitute, because again, it's kind of like a little formula. It says, in order to find x, use this formula. Do negative 3 multiply, come on pen, negative 3 times your y value, which we just found was 11, and then add 3 to that. That should be our formula to find x. So if I do that, I get negative 33. X equals negative 33 plus 3. And then add that, I get negative 30 for my x. Again, if you give me that as your answer, I'd be okay with it. I mean, those are the two values, but ideally what I want to see is an ordered pair. So x is first, even though we found it second. So negative 30, comma 11 would be where these two lines intersected if I were to graph them. Those are the two values that make both equations true at the same time. So that is the solution to my system using substitution.